Hey guys, cool. The camera's not working. There we go. All right. Okay, so we are moving on to 2-6. So we are continuing to talk about proportional relationships, um, but we are actually going to start connecting this to the slope of a line. Do I want to hide this? I don't know. It's kind of a pain in the butt. No, it's two right now. I guess it's hidden. I can drag this around too. Look at that. Okay, I'll leave it right. Okay. So for this word problem right here, in the fall, Rashida earns money as a soccer referee in her town's under 10 soccer league. Wow, I did that when I was a kid too. Yeah. My first job, actually. I hated reffing soccer. So far, she has worked 5 games and has been paid $98.50. She will work a total of 14 games this fall. How can Rashida determine how much she will earn refereeing games this fall? Well, we're going to use the technique we used in our last when we were talking about all those movie prices and we did our notes day for this, right? You take the total amount paid and then you kind of divide by the number of games, and that gives you how much you earn for one game. And then we'll take that money, and we'll take that price that amount of money, and then we'll multiply it by 14 games to figure out how much she gets for 14 games. Yeah, that's it. All right, so we take this 98.50. And we're going to divide by 5. And please, please, please show your division as a fraction rather than using the division symbol. In circumstances like this, we're going to take that 98.50. We'll divide by 5 again. Use calculator, guys. And she makes 19.70 per game. All right, so it's a decent amount of money for a teenager, I guess. So 19.70 per game. Now, if she's doing a total of 14 games, right, then all we have to do is take that 19.70 and multiply by 14. Okay. We can even label this, right? So this way, when we combine them, we'll have our label already. So let's see, 19.7 times 14 gets us $275.80. Yeah, I don't know. Fairly simple, right? Again, you figure out how much it is per one game, and then you multiply that amount by how many games she's planning on reffing, right? That's your thing right there, right? So discuss with your shoulder partner. How did they solve this? Well, I figured out the price for one game. Let's say amount rather than price. The price is a weird thing to say. The amount for one game, and then multiply that by the total games. By the total number of games. So I don't know, fairly simple, right? It's only a little bit of division and then a little bit of multiplication. You've got a calculator for that. So the math itself shouldn't be too hard. You just have to understand conceptually that for what we are doing, you want to get down to 1 unit. We call this the unit rate. Okay. The unit rate basically means, for one game, it's 1970. So that's the unit rate for this problem. Okay. So that's the idea here is for a lot of these, you want to think in terms of that unit rate. That's kind of what those proportional relationships, that's all we did the last couple days, okay? Okay, Maya and her father are building a treehouse. The roof will have a 9/12 pitch. That is for every 12 inches of horizontal distance, which is, oh man, sorry, this is, I shouldn't, yeah, I don't know, in black and white it doesn't really show up, but please realize that this is what it's talking about right here. That's that 12 inches. That 12 inches of horizontal distance, the roof raises 9 inches, right? So that's 12 and that's 9. So how can Maya determine the height of the roof at its peak? So we are looking for this value of x right here. And we know that according to the blueprint right here, the distance from the edge of the roof to the center of the roof is 6 feet. So we can use this information to figure out that x right there. So these are basically similar triangles. That's kind of the idea here. So we've got this table right here. We've got 9 for the vertical distance and 12 for the horizontal distance. We're going to divide the horizontal distance by the vertical distance, right? So let's see if I can fit this in here. 9 divided by 12. 9 divided by 12 gets us to 0.75. Okay. And then let's see here. How many inches is 6 feet? Oh, actually, hold on one sec, guys. Okay, yeah, sorry about that. Okay, so then to fill out the rest of the table, we're just going to be kind of like going up in increments of 9, right? So, and 12, right? So 9, if we double that, gets to 18. And then we double that 12, we get to 24, right? So if we're doubling the vertical distance, you have to double the horizontal distance. And then let's divide that out, right? 18 divided by 24 gets us to 0.75. Look at that, right? You can also think of that as 3/4 if you convert that 9 to 12. Actually, yeah, let's look at it in terms of 3/4. That's what I'd rather do. So then we take 27 and 36 because we basically add another 9 here and another 12 here. And let's do that. Or let's simplify it, right? We take the top, we divide by 9. We take the bottom, divide by 9, and that gets us to 3/4, right? Or 0.75, same thing. And then, what is that, 36, right? Yeah, 36, and then 48. There we go. And same thing, we'll divide the top by 3. Top by 3. No, we'll divide the top by 12, and we'll divide the bottom by 12, and we get to 3/4. Okay, so the idea here is that we're going to graph our points right here, and I have a ruler actually to make my line a little straighter. So if you have a ruler, that'd be good. 9, 12 is 9. This is like halfway. Let's see what the horizontal distance is here, right? So the horizontal distance is going to be 12 and then 9, which is like, if this is 6, it's like kind of like halfway in between there, right there, okay? And then 36 and then 27 is going to be kind of halfway in between there because like this is 30 right here, and then halfway between 30 is 27, right? And then 48 and 36 right here, right? Is that right? 48. No. What am I doing here? Yeah. 48 for the horizontal distance, 36 for the vertical distance right there. Now am I missing something? 9, 12, 18, 24. Oh, not 24, 18, my bad. Sorry. Which would be right there in between. Yeah, sorry. This 24 for the horizontal and 18 for the vertical. Okay. So now we've got our line right here. I am going to be very careful. Okay. And then we want to figure out how we can determine the height of the roof at its peak. Sorry, I'm right here, right? So we've got our graph right here, and we've got our table right here. So we could, kind of like extrapolate this one out. We can also use the graph to extrapolate this one out. So let's see, 6 feet is 72 inches, right? Because you take 6 times 12. 6 times 12 gets us to 72. So we know that this distance is 72 inches right here. And so then we got to kind of figure that out because that would be the horizontal distance here for 72. And it's actually going to go off the grid right here. So that's not great. Keep coming in. Sorry about that, guys. Okay, where was I? Okay, so we know that the horizontal distance is going to be 72 because 6 times 12 is 72, right? And so we can actually use our graph to do this, right? Because this goes up by increments of 12, right? Even though it's not labeled right here, this right here, that's 72. So we can go up on our graph right here and find out kind of where it goes through. So it's right there, which is halfway in between 48, and let's see, 12. So this is 54 right here. Well, actually, no, it's right on the corner. So I think my graph's off a little bit. So right there is 54 because that's halfway between 48 and 60, right? Because you add, it's 12. It's a difference of 12. And so if you add 6, which is halfway, you get to 54. So my graph's a little off because it should be directly on that point right there. So that's 54 inches. And so that kind of vertical distance is 54 right here. So if we can double check our work and we say 54 divided by 72, we should get 0.75 right here. Boom, we did. Okay, so our vertical distance is 54 inches. Okay. And so, yeah, we extrapolated off the graph right here. If you wanted to, you could actually use the slope right here. That's what that's called, to figure that out, right? Because we got to figure out this one, that x value. And so you just put it into an equation to do that. And that would be how you figure it out, because 72 times 3/4 should give you 54. So 0.75, yep, 54, just like that. Yeah. Okay. I'm going to shift color here. The graph represents the depth of a diving submarine over time. At what speed is the submarine descending? So the idea here, guys, is we want to figure out the kind of how steep this line is. We know it's going down, and we know that because the graph itself, the line itself, is going down, and these are also negative. Okay. So the idea here is you want to find 2 points on the grid. Let's see here. There's a good one. There's a good one right there. And there's a good one right there. So this is, let's see, 5, negative 400. Okay. And then this one is 10, negative 800. Okay, so to do this, we use a formula called slope formula. It is m equals y2 minus y1 over x2 minus x1. Now that m is our slope. So that is what we're looking for. And now in our points right here, we have an x value and a y value in each one. So actually, I'm going to write the points out here. I'm going to do it a little bit bigger. So I've got 5, negative 400 as our first point. And then I've got 10, negative 800 as our second point. And now I'm going to kind of assign each of these points, each of the numbers in the points, one of these values, right? So since this is our first point, this is x1 and this is y1. And since this is our second point, this is x2 and that's y2. So now we take these and we plug it into our equation, right? So it's going to be m equals y2, which is negative 800, okay? And then we're subtracting y1, which is negative 400. Make sure you're keeping your negatives consistent. And then we put it over our x values, which is 10 minus 5. Okay. So let's see, negative 800 plus 400. I'm just going to put that in my calculator. I know it's going to be negative 400, but it doesn't hurt to double check. Let's see. Nope. Boom. So negative 800 minus a negative 400 gives us a negative 400 on top, and then 10 minus 5 is 5. And when we divide that, we end up getting, is that 80? Yeah, that's 80. So m equals negative 80, which in this case is 80 feet per minute. Yeah, so maybe I'm running out of room here. So 80 feet per minute is how it is descending, just like that. Okay. Okay. For interpreting slope, one other thing that I do want to address here. Okay, so you can also figure this out by kind of making a triangle on your on your graph right here, right? So the idea here is you want to make a right triangle, and then you'll kind of figure out the difference right here. We have negative 400 and negative 800. The difference there is negative 400, which we already know that. And the distance from, let's see, 5 to 10 is 5, right? And then you have this negative 400, and you're going to divide it by that 5. So this is the rise. I think you have heard this term before. And this is the run, right? So slope is going to be rise divided by run. Okay, so we will, don't worry, you will hear this so much. We will talk about this a lot. Okay, so let's see, the graph shows the distance the car travels over time. Find the slope of the line. What does it mean in the problem situation? Gosh, that's a terrible way to word things. Okay, so we have hours versus distance. Okay, so let's figure out our rise. It's a difference of 220 to 110, so that's 110 right there. That's a difference. And then let's see, it's 4 and 2, so it's a difference of 2. So we take our rise here and our run here, and we divide them, right? Because it's rise over run. So n is rise over run. Remember, n is our slope, and which is going to be 110 divided by 2. Sorry about my texts, guys. I'm blowing up. 110 divided by 2 gets us to 55. And then let's use our units, right? So 55 miles divided by hours. Because again, right, if we just kind of like this is distance on top, and this is time on the bottom. Right, we talked about this a little bit. So it's distance divided by time, which is miles divided by hours, or miles per hour. That's how you figure out speed, right? So that's the speed of this car is 55 miles per hour. I drive 55. Sam Neill, old song from the 80s. Kind of sucked, but I don't know. Okay, so fold that in half. I'm going to get my notebook somewhere. Where is my notebook? There it is. All right, this is going to go on page 24. Okay, so page 24. This is 2-6. I'm just going to say proportional relationships and slope. You do not necessarily need to say connect. And slope. I will glue this in later. You do not need to see me do that. And then for the table O contents, we have 2-6. If I could actually write proportional relationships and slope on page 24. There you go.